Em, and today we're going to talk about how to simplify fractions with complex radicals. And if that sounds really confusing or scary to you, just remember radical is the same thing as a root, okay? So we're just simplifying fractions with complex roots. So to start today, let's just remember, what does it look like when we just simplify a radical in general? So if we have the square root of 120, what's it going to look like to simplify that? Well, remember, we always start with a prime tree. So we have 120. And if you see any number inside of a root and you're making a prime tree of it and it ends in 0, you're going to want to divide by 10. So we take 12 and 10. Then we split those up into their parts, which gives us over here 12 is 2, which is a prime, times 6. And 6 is 2 times 3, and both of those are primes. Over here we have 2 and 5, and those are both primes. So now we have root 120, but instead of root 120, we're going to write the product of primes, which is going to be 2 times 2 times 2, see, 1, 2, 2, 2, and then 3 and 5, times 3 times 5. And we always want to make sure our square root or our radical covers all the terms inside of it. Now we circle our pairs. We only have one pair of numbers there, and that's going to go out. So we're going to have 2 root 2 times 3 times 5, which is 2 root 2 times 3 is 6. 6 times 5 is 30. So we have 2 root 30. And that's it for that one. So now let's take a look at another example. Let's go a little more complex this time. This time we have 3 plus or minus 5 root 27 over 6. Okay, so you'll notice that this look, if you remember from last week, this looks similar to how problems look when we've finished simplifying a quadratic function. So we're just practicing with that, okay? So we have 3 plus or minus 5 root 27 over 6. Remember, step 1 is always that we simplify the number inside of the root. So in this case, that number is 27. We make a prime tree out of this. 27 is 3, which is a prime number, times 9. 9 is 3 times 3. Okay, so we're going to have 3 plus or minus 5 root 3 times 3 times 3. That's our product of primes. Now we circle our pairs, and we know that that pair is going to go out, and it's going to be multiplied by the number that's already there. Remember, this is 5 times root. There's a multiplication symbol there. Remember, whenever you don't see any sort of operation symbol like plus, minus, divide, and it's a number is directly next to something else, that's always going to be a multiply. So, oh, and all over 6. So that's the same thing as 3 plus or minus. Well, we're taking this 3 out, and we know we're multiplying it by 5. So we do 5 times 3, which is 15, root 3. We have 1 left over 3, and remember, leftovers go in things, over 6. Okay, now the number inside of the root is as simplified as it can be. So now we need to deal with these numbers. And these numbers, to me, all look like they're divisible by 3. So we're going to divide each of these by 3. Remember, that's when we draw our little triangle. And any number inside of the triangle, we try to see if it's divisible by the same number. And in this case, it is. It's divisible by 3. So we're going to get 3 divided by 3 is 1, plus or minus 15 divided by 3 is 5, root 3, all over 2. And that would be our answer. And remember, this is technically 2 answers. 1 plus 5 root 3 over 2 and 1 minus 5 root 3 over 2. Okay, so we've got 3 more examples to take a look at. This next example is the square root of negative 80. Okay, so remember, anytime we have a number inside of a root, we always start by a prime tree. But you also need to remember anytime you see a negative number that we're making a prime tree out of, our first step is always to factor out that negative. So our first step is always writing -1 over here, and then we'll write the number 80. So 80 ends in a 0, so I know I can divide it by 10. I'm going to get 8 and 10. 8 is 2 times 4. 4 is 2 times 2. And we're done on that side. Those are all primes. 10 is 2 times 5. 2 and 5 are both primes. So we're done with that. And -1 is a prime. So we're going to write the square root of, and we're going to write all of the primes, the product of the primes. -1 times, we have 2, 2, 2, 2, so 4 2s. 2 times 2 times 2 times 2 times 5. Circle our pairs. And also, I like to circle my -1 because I like to circle anything that I know is going to go out. -1's going out, that 2's going out, that 2's going out. 5 is a leftover, so it stays in. So I'm going to have 2 times 2 times I. Remember, -1, when we pull it out of that square root sign, we turn it into an I because that tells us that we had a negative inside of a root and that our answer is going to be an imaginary number. We still have our leftover inside of the root, so that's our root 5. And then I multiply these to get 4I root 5. Okay. And one thing that I don't have that I need to have is my plus or minus. Plus or minus 4I root 5. Okay, next. This time, let's look at the square root of -16. Okay, now you probably recognize that 16 is a perfect square, and so we could pull out the 4, but we need to remember that this is actually -16, and when we have a negative, the first thing we do is we take out our -1. So you could, if you recognize this is a perfect square, what you could do is you could say, okay, well, that's -1 times 16. And then you would know that that is an I and that this is 4. 16, the square root of 16 is 4. So you could write 4I. Okay, but maybe you didn't recognize that that's a perfect square. That's totally fine. You can go through the prime tree method. 16 is 4 times 4, and each of those 4s is 2 times 2. Okay, that's going to give us -1 and then 4 2s. -1 times 2 times 2 times 2 times 2. Circle our pairs. I like to circle that because it's also going out. Notice we have nothing left over. That's why over here, our square root sign went away. So we get 2 times 2 times I, which equals plus or minus 4I. All right, final example for this video. 4 plus or minus the square root of -32. You can probably tell this week we're going to have a lot more negatives over 10. Okay, 4 plus or minus root -32 over 10. First step, simplify the number inside of the radical. So we've got -32. We have to take out that negative, and that leaves us with a 32. 32 is 8 times 4. 8 is 2 times 4. 2 is a prime. 4 is 2 times 2. Those are primes. And up here, 4 is 2 times 2. Those are primes. Also circle the -1. That's a prime. So over here, I like to simplify my root over here and then plug it back in, just personal preference. So I have -1 times 1, 2, 3, 4, 5 2s. 2 times 2 times 2 times 2 times 2. Okay, now I circle my pairs, 2, 2, and my -1. So that's going to go out, and so are those. This 2 is left over. It's going to stay in. When these come out, they're going to multiply, and that's going to turn into an I. So it becomes 4I root 2. So now I go back over here. Instead of root negative 32, I have 4I root 2. So 4 plus or minus 4I root 2 over 10. This is simplified as far as it can go. So now I'm going to draw my triangle and try to simplify. Well, each of these can be divided by 2, which is going to give me 2 plus or minus 2I root 2 over 5. And that's it. Okay, so that's it for video 1 this week, and I will see you guys later.